What's going on, everyone? Welcome back. Patrick here, and in this next example, and actually in the next couple of examples, we're going to talk about combining functions. And we're going to go through a couple of complex scenarios, and in a lot of the examples, we're going to have to state the domains of the combined functions. So I actually highly recommend that you go over, if you haven't yet, earlier in the course on finding the domains of functions, especially those complex examples. Because a lot of these examples, when we end up combining certain functions, we're going to end up with similar functions that we covered before. So I highly recommend you go over those domain questions just so you have some good fundamentals, a nice base before covering these examples. So in this video, we're told if f of x equals x squared minus 4 and g of x equals x minus 3, we got to find these 5 different functions: f plus g, f minus g, f times g, f over g, and g over f, and then state their domains. So let's go through them one by one. So we got f plus g. This one's pretty simple. All we're going to do is just add these two functions. And when you add them, what would you get? You'd get x squared plus x, and then minus 4 minus 3 gives us minus 7. So notice this just ends up being a regular parabola. And for a parabola, what is the domain? The domain is x, ER. And in interval notation, we could say x is an element between negative infinity and positive infinity. Right? So fairly simple function there. And then we got f minus g. This one's going to be simple too. All we do is we take x squared minus 4 and we subtract x minus 3. Make sure that when you subtract it, you put it in brackets. We're subtracting that whole function. So now we got to distribute that negative inside the brackets. So we'll have x squared minus x. The negative 3 turns into a positive 3. Negative 4 plus 3 gives us minus 1, which is a parabola as well. Same thing as here. So domain is just XER. X can be anything. And then in interval notation, we got x is an element from negative infinity to positive infinity. Moving on, we got f times g, which would be what? X squared minus 4 times x minus 3, like that. And notice that this is just a polynomial. It's still a polynomial. You can actually factor x squared minus 4, which is x minus 2, x plus 2. And then we got x minus 3. And so you can actually do a rough sketch of this. So we would have an x-intercept at 3, at 2, and then at negative 2. Notice that the leading coefficient will be positive, and it's an odd degree, right? Because the highest degree is going to be x to the power of 3. So we know the end behavior is going to be here and here. So it's going to look something like that. Right? So you don't necessarily have to graph it. Just wanted to show visually, though, roughly what's going on. And so from here, we can tell the domain of this is also XER. Right? This keeps going to infinity, right, for the x values to infinity, and then this keeps going to negative infinity in terms of the x values and the y values as well, but we're only dealing with domain in this question. So in interval notation, x is an element from negative infinity to positive infinity. And then we got f over g and g over f. So that's usually these types of questions, that's when stuff can start getting more complex, especially with domain and range. So f over g, what's that going to be? It's going to be x squared minus 4 over x minus 3. And you always want to factor everything just to see if any factors cancel out. In this case, there are no factors that are canceling out. And so from here, the domain, it's not just XER, but notice how x cannot equal 3 there. Because if it equals 3, then the denominator is going to be 0. You can't divide by 0. So we would say x can be anything, but it cannot equal 3. And in interval notation, we would say x can be from negative infinity to positive 3, not inclusive of positive 3, so we put a circle bracket there, or it could be from positive 3 to positive infinity, not inclusive of the 3 there as well. Right, so for f over g, that is the domain. And then we got g over f, which is going to be what? X minus 3 over x squared minus 4, like that. And if we factor this, we'll have x minus 3 over x minus 2 times x plus 2. So notice in this case, we got 2 vertical asymptotes. So the domain here is going to be xer, but x cannot equal positive 2 or negative 2. So let's just put plus or minus 2 here, like that. That's going to be the domain. And in interval notation, it's actually going to be a longer line. There's going to be more intervals because there's 2 of these restrictions. So in interval notation, it'll be x is an element from negative infinity to negative 2, like that, or from negative 2 to positive 2, not inclusive of negative 2, not inclusive of positive 2, or from positive 2 to positive infinity. So in interval notation, that would be the domain for that function.